All right, hello, welcome to the last page. Go ahead and get this one done quickly as possible. So, example 6, we're going to determine whether 1.21 guarantees that a difference equation possesses a unique solution through the given point. And so here we have the 0.53. And what we're going to do is we're going to go ahead and look at our f of x. So when we look at f of x, we get square root of y squared minus 9. And if we look at our partial of our function with respect to y, taking that, we get 2 y on top, but divide by 2 because that's going to go in the denominator. So we get y over the square root of y squared minus 9. Again, just taking the derivative of our function with respect to y. And so here we see that in order to have a unique solution, it's going to be determined that y has to be less than -3, and y has to be greater than 3. And because we're the 0.53, there's no guarantee of a unique solution. Gotta spell guarantee right. I love being a math teacher. Guarantee of a unique solution. That should be an A. All right. So yeah, that's all you have to do. You just have to find where we would have a unique solution. So the last one showed that a solution from the family y equals -1 over x plus c that satisfies y prime equals y squared. So we're given the solution to A. We're told that, here's our solution, and what we want to do is we want to determine if y sub 1 equals 1, at y sub 1 equals 1, we're going to find c, and we're going to see if that actually is y equals 1 over 2 minus x. So we're just going to plug in real quick to our solution. So A, we have our y value, which is 1, is equal to -1 over x, which is going to be 1 plus c. And then we're going to solve, so I'm just going to cross multiply, get 1 plus c is equal to -1, subtract c is equal to -2. So yes, that is a solution. So we have 1 over, let me make sure, -1 over x plus c, which is going to be x minus 2. There's our solution, which can be rewritten, get rid of the negative, or just, rearrange where the negative is at, and y is equal to 1 over, then switch the denominator, so 2 minus x. So yes, that's a solution. If we do B, we'll do the same thing. We're going to plug in, but this time we're going to plug in 3 for x and -1 for y, so -1 is equal to -1 over 3 plus c. Bring over the 3 plus c and multiply, get -3 minus c is equal to -1. I'll add c to the right and then add 1, so c is equal to -2. And then again, we're just going to plug that into y equals -1 over x minus 2, which is just going to give us the same thing, y is equal to 1 over 2 minus x. So they give us the same, the way it looks is the same, all right? Both of these are very similar in the way that they look. But then this says, are the solutions the same? Well, are they the same? Well, if we look at A, and we look at our function, actually here's our solution. All right, we know one thing. It's there's a domain for this. The domain for y, this should say c. The domain for y equals 1 over 2 minus x. The domain is going to be from negative infinity to 2 and to infinity. So when we talk about existence and uniqueness, these are not the same, because for A, because we're dealing with a point 1, 1, all right, we're dealing in this region, not that region, but this region right here. So for A, we're from negative infinity to positive 2. But for B, I hate this. We're going from 2 to infinity for our interval because of the point that we're given. All right, because we're given negative 1 for y, 3 for x. So because they're in two different regions, they are not the same solution. All right, we have two different intervals, so it's no. All right, and that does it. Again, any questions, come see me, and I hope that